might have to start again.
No, that's all right. Okay. Well, thank you very much, Lee, for that introduction, and thank you, everybody, and thank you to those watching online as well for the opportunity to talk to you about this issue of how we incorporate methane into agricultural policy and climate, how we incorporate agriculture indeed into climate policy. And the first thing I'd want to say to emphasize is that we've got a challenge here, we've got an obstacle, and we have an opportunity. The challenge is that methane is a very important greenhouse gas. It's a gas whose importance you can spin. So I see claims that methane is, that the Global Methane Pledge website claims that reducing methane is the single most important strategy we have for meeting the goal of 1.5 degrees. That's what they say on their website. And it's like, well, apart from stopping fossil fuels from causing global warming, they forget to say that on the website. So, there is an elephant in the room here, and that's warming caused by fossil fuels, but nevertheless, methane is an important additional contributor, and to meet our climate goals, we need farmers' help. Reducing methane emissions as well as increasing carbon storage on land are two of the ways in which farmers can undoubtedly help us meet our climate goals. The problem is we've got a widespread misunderstanding and confusion about how methane influences global climate. And a lot of this is summed up in this notion of carbon dioxide equivalence, or the carbon footprint, which I'm sure many of you will be familiar with, which, as it were, pretends methane is a kind of carbon dioxide, and it isn't. And we have to address that, and in addressing it, we have an opportunity. Because I think the opportunity is if we were to refocus climate policy on warming outcomes rather than emissions inputs, we might actually find it much easier to engage farmers with climate policy. We might make climate policy more effective and get faster reductions in methane emissions than we might do otherwise. So first, do not on any account take away from this talk the message, relax, there's nothing to see here. In some ways, there's more to see here than perhaps you thought, but it is perhaps different from the impression you might have got from conventional carbon footprint type tools. So I did a bit of data crunching before this talk, just to sort of put this into context, but I'd like to stress this is just data downloaded from the Primate website there. I don't know. I think the Primate website it's a global website which compiles data on emissions from individual sectors, but I'm sure there'll be people here who are probably much better acquainted with Australian agricultural sector emissions than I am, and would no doubt want to quibble, oh no, it wasn't 80, it was more like 70 or whatever. But I'm showing you these figures simply to give you a clear feeling of how methane behaves. It is an estimate of what Australia's emissions, the emissions of Australia's agricultural sector have been. And this is expressed in the conventional carbon footprint form. So this is expressing carbon dioxide, nitrous oxide and methane, the three main greenhouse gases, in so-called carbon dioxide equivalent units. And you'll see that on this metric, methane is by far the dominant contributor to the footprint of Australian agriculture, and if we add it up over time, you can see that footprint is ever growing as a result of the accumulation of all of these emissions. So that's the picture. If you got a copy of the Sydney Morning Herald, which would tell you how much is agriculture contributing to Australian emissions, there'll be a number, and it would be based on that figure on the left there. It would be based on this kind of calculation. By the way, there are other metrics out there. This is the 100-year global warming potential, which is the standard unit of currency that people use to convert methane to carbon dioxide equivalent. It's used by most trading systems around the world, not all. But there are people out there as well who argue instead we should use the 20-year global warming potential, which actually presents you with a very different picture, even larger contribution from methane. And of course there's Brazil that argues we should use something else called the global temperature change potential, which would shift the methane line down by a factor of 8 or so. So there's huge room for argument in what is methane actually worth. And the reason for that is actually because the actual contribution of methane, so before I get on to sorry about the apologies, before I get on to the reason for that, I'll just talk to you a little bit about what methane's actually doing. So that's methane emissions, and this is the contribution of these emissions to temperature change, to global temperature change. Now, just to sort of draw attention to some of these lines, we're going to come back to this, but this is a way of illustrating how important it is to appreciate the different behavior of these different gases. So notice so nitrous oxide emissions have gone up and then leveled off a bit. Yeah, you can see that green line on the left there. If we look at the warming caused by nitrous oxide, it just goes up. Yeah, nitrous oxide accumulates in the climate system, as does carbon dioxide. The more nitrous oxide you produce, the warmer it gets. It's not a matter of how fast you produce it, it just simply adds up. 1 ton of nitrous oxide causes a certain number of millikelvin of warming. So far, so simple. Methane, you'll notice, is very different. So methane emissions are continuing to accumulate here, but methane-induced warming has peaked and is going downwards because methane emissions are falling. And this is methane emissions from Australian agriculture. Globally, methane emissions are still rising. So globally, methane emissions from the agricultural sector are still rising. So I'm just focusing on Australia's agricultural sector here. The left-hand panel is something which people don't talk about much, which is contribution to the rate of warming. And I've calculated over the preceding decade, because year to year it's going to bounce around a bit. And that's basically just the slope of this line. And you'll notice it's gone negative. And this may puzzle you because emissions from methane are still positive. Yeah? We shall now talk about why. Just so the important thing is you take away from this an understanding of how it is that methane affects global temperature, and so that can inform the conversation. It doesn't dictate the outcome, but just to inform the conversation about how we deal with it. So this is just summing this up. Methane and carbon dioxide are not equivalent in the terms of their impact on global temperature. When emissions are rising, both of them cause, so the upper little schematics shows rising emissions of carbon dioxide, rising emissions of methane. Imagine that scenario. Both are going to cause warming. You'll notice the carbon dioxide actually curves upwards because if rising emissions of carbon dioxide means it's accumulating ever faster in the climate system, so you get accelerating warming. Rising emissions of methane, it's pretty much a straight line warming, but it's still warming. So you can't really tell much of a difference between them. That's, if you've got rising emissions, they have apparently equivalent impact on global temperature. When we go to constant emissions, you'll see that the constant methane emissions do still cause some warming. So that line isn't completely flat. It's still going up slowly because the system is still recovering from adjusting to the impact of past methane emission increases, even though they've stabilized. But constant carbon dioxide emissions still drive a lot of warming. It still accumulates in the system. Where we see a big difference is when emissions are falling. And that's why, of course, we saw these big differences in the impact of Australian agriculture in that previous figure. As carbon dioxide emissions are falling, we see carbon dioxide-induced warming slowing down. But it doesn't stop until emissions reach zero. Because carbon dioxide accumulates in the climate system, the only way to stop carbon dioxide causing further global warming is to get carbon dioxide emissions to net zero. That was the sort of key result in the late 2000s that kicked all this off. But methane emissions behave totally differently. If you're reducing methane emissions, the warming they cause falls, because methane has a short lifetime in the climate system, unlike carbon dioxide, which persists, the impact of carbon dioxide persists essentially forever. thousands, tens of thousands of years. Methane, it's natural gas, it oxidizes. It oxidizes in the atmosphere with a lifetime of around 10 years. And as a result, if you reduce methane emissions, the amount of methane in the atmosphere follows them down, and you see the warming it causes following down along with it. It doesn't go all the way back to zero. There is still some residual impact of past methane emissions, but it's completely different behavior to the behavior of CO2. So people, you'll easily find people who'll tell you, if you want to follow up, interviewing, I can give you a whole list of scientists to follow up if you want to interview them, who'll tell you, there's no problem here, we can still use a CO2 equivalence, it's all fine. They're talking about this situation. And globally, that is the situation we're in. Emissions are going up, so treating methane and CO2 as equivalent, sort of kind of, everybody knows it's not ideal, but it's sort of good enough. At least that's the argument. But as soon as we get into a regime where emissions are actually coming down, and we've got to hope that we're going to get into that regime globally, this is going to start to become a major issue. Because that's where the differences in behavior really come out. So it's really important to stress, this is not exciting new science. Sorry, Alan, this is very exciting science, but it's not new science, okay? This is a paper led by Alan Lauder back in 2012, yes, and well before I was even thinking about methane. I was worrying about carbon dioxide at this time. He introduced an idea for how you could quantify the impact of methane emissions in offsetting, in considering how they might offset other gases, which essentially is this talk. So I'm not really, conceptually, I'm not really adding anything to what Alan did back in 2012. What we did, I guess our contribution to this has been to add a few more numbers, refine the formulae a little bit, make things a bit simpler, but conceptually all this is very, very well established and has been established for well over a decade. In fact, if you're pedantic, you can argue, you can go back to Keith Shine's paper in 2005 and it's all there as well. I mean, this is not controversial science. The policy implications are somewhat controversial, particularly in Europe, where the policy community is very, very wedded to the carbon dioxide equivalence framing, and so people sort of like to say it's controversial, but it's important to be clear, it's not the way methane affects global temperature that's controversial. Some of the policy implications are controversial for some. There's been Brad Ridout here in Australia has actually been looking very specifically at the impact of the GWP star climate metric, which I'm going to be talking about in a minute. So I just wanted to give point out that paper, because I think it's always good to ground this work in the published literature that came out quite recently, and I think Brad Ridout would be a great person for you folks to engage with if you wanted to follow up on these topics. Unfortunately, he was away at the moment, so I haven't actually had a chance to talk to him on this trip, and I'm hoping to follow up with him, and certainly somebody for you to talk to afterwards. So just to really emphasize the uncontroversial nature of the science here, there's a sentence here which, forgive me if it seems a little bit, a lot of words on the PowerPoint, but it's a sentence worth digesting because it really does distill out the whole problem, and it's from the IPCC, the Intergovernmental Panel on Climate Change's sixth assessment report, published a couple of years ago, and therefore you can be sure it's been very heavily scrutinized. So nobody's arguing with this statement about the way things are. And what it says is, expressing methane emissions as carbon dioxide equivalent using 100-year global warming potential, which is the standard way of doing it, overstates the effect of constant methane emissions on global temperature by a factor of 3 to 4, while understating the effect of any new methane emission source by a factor of 4 to 5 over the 20 years following the introduction of the new source. Now, if you think that sounds like a bit of a headache-inducing sentence, I can't make it any simpler than that. That's the way it is. Okay? I think Einstein told us, make everything as simple as possible, but not simpler. So when I hear this, people say, well, can I average those two numbers and get 0, for example? So one's overstating, one's understating. No, sorry, this is the way it is. Okay? So the crucial point here, these are big errors. A factor of 3 to 4, 300 to 400%. This is not some academic quibbling over 20% here or there. Okay, these are big differences in the way the gases behave. First point to make. Second point to make is, there's a whole sentence here, don't stop reading at the comma. And I think there has been a bit of a tendency for the farming community to stop reading at the comma. Yeah? Because obviously the first half of the sentence seems quite positive. Good news for you? You've got to look at the second half as well. I really emphasise this with Irish farmers, particularly Irish dairy farmers, who fully intend to introduce lots of new methane sources, i.e. lots of new cows, over the next, well, I don't know whether they've been persuaded not to, but that was certainly their plan a couple of years ago. And that conversation went as you might have expected it went. There's lots of things you can follow up. If you really want a good explanation of this, John Lynch wrote a nice review article which really sort of distilled all this out, which is available for free in Environmental Research Letters. And just to really nail down that we have consensus on this, there's an article published last year which I led where we Googled everybody who'd published on metrics since the Paris Agreement. So that's why we didn't email you, Alan. You hadn't kept up the work. Basically, we had to sort of put a cut-off somewhere. Apologies. And it was bad enough with the people, so that was sort of 30 or 35 authors or so. You can imagine it was a devil's own job getting everybody to agree on wording on that. But the consensus statement which came out of that was that we need separate treatment of methane from carbon dioxide in setting climate targets. And that's the one thing absolutely everybody agreed on. If you want to know the impact of your targets and policies on global temperature, you've got to keep these things separate. There's no point in pretending they're equivalent. And so everybody agreed on that, but it doesn't seem to have so far made any difference. All the scientists are saying the same thing, separate these things out. The likes of UK government or European Commission are saying, well, no, we like to mix them up. And so I think it's, we've said what we can say. I'm not quite sure what more we can say as a scientific community. And now it's kind of going to be over to you to digest all this and talk to your government folk about what it would take to change things. So just to emphasize some numbers here, and because I think I'm a numbers person and numbers are important here, and I think it's really important that we actually work with the numbers, because the numbers are not controversial. The sort of words tend to be made controversial. When I'd say, for example, falling methane emissions cause global cooling, a lot of people get instantly upset. No, you shouldn't use the word cooling there, because what it's doing is undoing the warming caused by past methane emissions. Okay, I mean, we can have a debate about whether that's an appropriate use of the word cooling, but the point is, the numbers, it's harder to argue about. So I'm giving you the numbers here. The standard formula is you take your methane emissions, multiply by 28, and you get your CO2 equivalent emissions. If you want to know the CO2 equivalent, the CO2 warming equivalent emissions, that is the CO2 emissions that would give you the same amount of warming, or in this room, can I use the word cooling because it's a whole lot easier, but prevented warm, non-warming, the same amount of warming that you would get from your methane emissions, you need to actually multiply this year's methane emissions by a much bigger number, 128, but subtract your methane emissions from 20 years ago, multiplied by 120. Okay? So people already think, he's just giving us a maths lesson. Okay, but bear with, because that statement alone helps you understand both the problem and the solution. So it's worth hanging in there. Okay? And because the point is, if you add up warming equivalent emissions, you get the impact of your farm, your country, your industry, whatever it is, on global temperature. So it's an interesting thing to know. And so if you've got constant emissions, so your emissions 20 years ago are the same as what they are now, the difference between those two numbers is only 8. That's a factor of 3.5 smaller than 28. Hence the statement that if you have constant methane emissions, the standard CO2 equivalent warming, treating your methane emissions as CO2 equivalent overstates their impact by a factor of 3.5. So far so good. I'm getting a lot of nods here, so I'm going to encourage to continue. If your emissions have risen in the past 20 years, and I really want you to focus on this step, okay, before you go and buy a whole lot of new cows, okay, you need to multiply those new emissions by 128. Any increase in methane emissions has a huge warming impact on global temperature. And globally, livestock emissions are going up, and that is causing a lot of warming. So we have a problem here. Don't let anybody tell you, don't worry about methane. Interestingly, if your emissions have fallen by 6% over the past 20 years, so 0.3% per year, then, so a factor of 8 over 120, so 8 is the difference between them, 120 is what they were 20 years ago, so that's where the 6% comes from. Then, if you sort of gaze at this formula, a rather interesting result comes out. Your emissions are 6% lower now than they were 20 years ago, but you multiply them by a rather bigger factor, and you suddenly discover that it's adding up to 0. That's because gently declining methane emissions at about 3% per decade have the same impact on global temperature as net zero's carbon dioxide emissions. Meaning they don't push global temperatures up, they don't allow global temperatures to fall, they just keep it steady. Of course, you can do more than that. If you reduce your methane emissions faster than 6% over 20 years, so faster than 0.3% per year, then you're having the same impact on global temperature as actively removing carbon dioxide from the atmosphere, pulling global temperatures down. So this is where we've got an opportunity. If we can reduce methane emissions from the livestock sector, we're doing the same favour to the world as planting trees to take CO2 out of the atmosphere. We're pulling down global temperatures. Let's talk about some numbers here. So this is the same graph I showed you before. Australia's emissions and cumulative emissions added up over time on the right. But now I've just added a purple line, which is so-called warming equivalent emissions, calculated with this simple formula, 128, this year's emissions minus 120 times the emissions from 20 years ago. And you can see that the warming equivalent emissions, i.e. the CO2 emissions that would give you the same warming as Australian agriculture's methane emissions, they've bounced around all over the place and recently gone negative. Because Australia's agricultural methane emissions have been declining, and that's drawing down cumulative emissions and drawing down global temperatures. So if you add up warming equivalent emissions over time, you get something that predicts impact on global temperatures. So, why does this, what are the implications of this? Well, if you use input-based accounting, so the conventional carbon footprinting, CO2 equivalent emissions, if you're a crop farmer and you reconvert your land to agriculture, to forestry, plant lots of trees, the trees absorb carbon dioxide from the atmosphere, and in Europe at least you can get a credit for that, and I think that's the same in Australia, for taking CO2 out of the atmosphere because you're acting to reduce global temperatures. That's not regarded as controversial in any way. If you're a livestock farmer who reduces global temperatures by reducing your stocking rates faster than 6% over 20 years, if your methane emissions were simply included in an emission trading system, the way many people suggest they should be, you would simply be penalised less. You'd be paying for methane emissions and you'd be paying for lower methane emissions, but you'd still be paying. So one farmer is being paid, the other farmer is simply being penalised less, even though both farms could have had exactly the same impact on global temperature, past, present and future. Because the chances are the crop farmer actually released, or their ancestors did, released a whole lot of carbon into the atmosphere when they cleared the land for agriculture in the first place. So that caused warming. And now they're reverting to forested land, so they're causing cooling. They're drawing CO2 out of the atmosphere. But they're only able to do that because the land was cleared in the first place. So they've got the opportunity to do that because they've got some land where the carbon's been taken out of that land in the past. The livestock farmers in exactly the same position. They can draw down global temperatures because their ancestors built up the herd and caused lots of warming when the herd was built up. So if you think about the implications of actions on global temperature, then these two farms could have exactly the same impact on global temperature, and yet under current policies they're treated completely differently. And I think we need, if we're aiming for a temperature goal, which we are, the Paris Agreement is very clear that we are aiming to hold the increase in global average temperature to well below 2 degrees and pursuing efforts to limit the temperature to 1.5 degrees. The target is global temperature. They don't mention emissions in the headline objective of the agreement. Then the most efficient way of doing that is to penalise actions that contribute to increasing global temperature, reward actions that reduce global temperature, and of course you've got to make sure that if you do reduce global temperature, those reductions are permanent. You don't want to reward people for reducing global temperature temporarily. So, what can we do here? What sort of practical things could you be arguing for? Well, recently, sort of slightly frustratingly, just after we published these papers saying there was a better way of doing it, the UNFCCC system, the United Nations Framework Convention on Climate Change, passed agreed in their sort of annual conference of the parties that they would all use 100-year global warming potentials. And we were told, right, it's all decided, go away, your research is irrelevant, shut up, okay? People will tell you this. They'll say, no, UNFCCC rule, if you go to the UK government with this point, I guarantee you the reaction from civil servants and 99% of politicians is, oh, but UN rules mean we have to use 100-year global warming potential. So go away, we're not interested. That's actually not true. UN rules allow explicitly, and I give you the quote here because it's important to recognize that these are the words in that agreement, in the UN rules, each party, that means each country, may in addition use other metrics, i.e. as well as 100-year global warming potential, to report supplemental information on aggregate emissions and removals of greenhouse gases expressed in CO2 equivalent. And they don't say what form of CO2 equivalent here. It means other forms of CO2 equivalent as than 100-year global warming potential. So, what could be more relevant to your reports to the UNFCCC than what you're doing to global temperature? We're supposed to be aiming to stop global warming, so countries could report what they're doing to global warming. No, not a single country reports the warming impact of their emissions. So we have a massive global convention system which is supposed to be stopping global warming, and nobody's reporting their impact on warming. It's staggering if you stop and think about it, okay? But they could. And, the UK has recently joined the so-called umbrella group of countries. This is developed countries not in the EU, so of course we've recently joined it. That includes Australia and New Zealand. I think Australia may be leading it at the moment. And it would be a really interesting development for, the sake of transparency, no more, for members of the umbrella group to start simply reporting the warming impact of their emissions to the UNFCCC in both their inventory reports, that's reporting what they're doing at the moment, and their so-called nationally determined contributions, what they're proposing to do in the future. I'd say additional information. I'm not saying don't report under the old system, but report additionally your warming impact. And it's easy to calculate. Formula involves 2 multiplications and a subtraction. The old formula involved 1 multiplication. Don't let anybody tell you it's too complicated. Other farming unions have been calling for this. National Farmers Union of the UK came out recently they say support the adoption of the GWP star, which is the formula I'm talking about here, to report in measuring the impact of methane. Beef and Lamb New Zealand has been working on this for some years, but sort of looking around on the web, and forgive me if I've missed something here, I'm not aware of any Australian farming union joining this conversation. I think you should, because it matters. We need to know the impact of our actions on global temperature. And it's something that Australia could really make a positive impact on international negotiations by stepping forward to improve the transparency of all of our reporting by reporting warming impact as well as the conventional carbon footprint. I'm not saying instead of, but I'm saying as well as the conventional carbon footprint. And that's the main point I want you to. So, a little bit of a technical briefing, but as I say, I think the numbers are uncontroversial. The words, and that's why I was giving you the formula, because the words, maybe people get anxious about words, but there's universal agreement on what the numbers are. They might, you might quibble, is it 128 or 125 or something? But the point is, the big principle, that's how you get an estimate of your warming impact is clear enough. And I'm very happy to take, I hope, lots of questions.